Hello students. In the last session we have discussed about the encoder decoder. You have discussed without encoder and the decoder it is the mux and the demux, multiplexer and the demultiplexers. This is also very helpful for that one in the mux and the demux for that circuits. This is the way also electronic circuit. It is many of the usages are there in for the applications of the multiplexer and the demultiplexer. Multiplexer means what? Multi means what? Many. Multi means many. Can we use that one? Mux are the many of the uses are there one in the coaxial lines and the optical fibers and in the signals. Can we use this one in the many of the signals giving into the one signal? Multiplexer is a what is the multiplex? Mux or a multiplexer. Multiplexer is used. Multi means many. If you are giving the number of inputs, you can get only a one output with the signals. Yes, it is a serial line can be used it as a it is a multiplexer. Mux means what? If you are giving the many of the inputs and you are getting the only one output, it is called it as a mux. In a multiplexer means many into one. A multiplexer is a circuit used to select the route any one of the several input signals to a signal in the output. Multi-position switches are widely used in the electronic circuit. However, the circuits that operate at the high speed required the multiplexer to be automatically selected. The multiplexer used for the digital applications, also called the digital multiplexers, is a circuit in the many inputs but only one output. By applying control signal, also known as selected signals, we can steer any input to the output. Some of the common type of the multiplexers are 2 is to 1 and 1 is to 2, 4 is to 1, 8 is to 1 and 16 is to 1. This 2 is to 1 can we write it? 2 is to 1 means 2 inputs, 1 output. 4 is to 1 means 4 input, 1 output. At the same way, 8 is to 1, 16 is to 1. Can we get it? Whatever the number of giving the inputs, you can get the only one output. Can we call it as a multiplexer? That is call it as a multiplexer. Yes. Multiplexer. That is a multiplexer. This is the block diagram of the multiplexer. If you have n number of the signals, it is a control lines. This is the output signals. N number of the inputs, my control lines can we use it? It is always a 2 raised to n number of the inputs. It is a serial line. Can we use it as a n? The y is a output, only one output it is there. This is the block diagram of the input lines. This is the block diagram of the inputs. I am going to tell that one. This is the block diagram. Can we write it one more also? Yes, this is the block diagram of that one. Can we write it? Y is the output. These are the 2 raised to n number of the inputs. These are the serial line. N number of the serial line. It's a mux. It is a Y is a output. This is the block diagram of the multiplexer. It is a block diagram of the multiplexer. I am going to explain about this one as a multiplexer. This is the block diagram of the multiplexer is. If you are giving the, I am first going to explain about the 2:1 mux. 2:1 mux can be explained. 2:1 means 2 is the input. Yes, I am going to use the D0 and the D1 are the input. These are the inputs. These are the inputs. I'm going to draw that one. I'm going to draw that one. Serial line. This is a S. This is the 2 raised to n means 2 will come. What is the n value? What is the one value? 2 is the answer. I'm going to, once again, I'm going to question that one. Here 2 raised to n equals to 2 answer it is there. What is the value of n? Value of n is 2 raised to 1 equals to 2. 1 is a n. That's why I'm going to serial. It is a serial line is a yes. Only 1 it is there. I'm going to write the truth table of the mux. Truth table of the mux means yes. Yes is a input. D0 and the D1 are the input lines. If S is 0, F is 0, D0 is activated. I am going to once again draw that one, circuits. Why? If it is a yes, D0 and D1. D0 and D1. If S equals to 0, the D0 is active. The in a Y, D0 will be the output. Otherwise, if S equals to 1, which one is active? D1 is active. The Y is equals to D1 is a output. This is the output. Are you getting my point? Yes. That's why I'm going to write the truth table of this one. I'm going to write the truth table of this one. I'm going to write the truth table for this one. I'm going to draw that one. Yes, not and Y. Y is the output. Yes, not I'm going to put it as a 0. Which one will on? D not will on that one. Yes not equals to 1. Sorry, yes equals to 1. D1 is activated. Now I am going to write the answer. I am going to write the answer for this one. What is the total output of the, what is the total output for this one? I am going to write the total output. Total output is y equals to this is the S bar D naught plus S D1. This is the S D1 can be write it. Y equals to S D naught plus S D1. Can we write it? Once again I am going to explain about this one. Y equals to, how can you write that one? Y equals to S bar, 0 is a S bar D naught plus S D1 will come that one. I am going to write the uh, circuit diagram. How can we write that one? S S bar D naught D. First one, S bar D naught, multiplication and gate, and second one is a S D1, it's a AND gate, both are in the addition OR gate. This is the Y, this is the Y, this is the Y, can be write it in the, this is the circuit diagram of the multiplexer 2 is to 1 mux. Let us discuss about the mux of the 4 is to 1. 4 is to 1 multiplexer can be write it. 4 is to 1 multiplexer can be explained about this one. I am going to write this one in the 4 is to 1 multiplexer. This is the, how many inputs are there? 4 inputs are there. 4 is to 1 is a 4 inputs are there. A, B, C, D. How many 2 raised to n equals to 4 means what is the value of n? 2 raised to 2. 2 is a yes serial line. Serial line of that one, it is the mux of that one. It is the 4 inputs. It is a y is the output. I am going to write this one as a inputs of that one. I am going to write that one. Yes, S0 and S1 are the serial lines. Inputs are, I am going to take Y0, Y1, Y2, Y3. These are the inputs. These are the inputs. Yes, this is the mux of 4 is to 1. 4 inputs are there, 2 serial lines are there. Can we write the truth table for that one? Can we write the truth table for that one? It is the input for that one. Yes, input that one. It is the, can we write it in the truth table? Y is the output. Can we write it? S0 and S1 are there. Y equals to, Y equals to, it is the, can we write it one more thing for that one? Yes, the truth table of the S0 and S1 are the serial lines. S0 and S1 are the inputs. 0 0 1 1 0 1 0 1 are the inputs. The output Y is 0 0. The both are 0 0. The Y0 is activated. 0 1 Y1 is activated. Yes, 10 y2 is activated, and third one is y3. It is like that can be explained about the mux of the output. Can we write it in the y naught equals to what will come for that one? S naught S1 bar bar. Yes, y1 equals to S naught bar S1, y2 equals to S naught S1 bar, y3 equals to S naught S1. S naught S1 will come for that one. I am going to draw for this one for the, yes, this is the y1, y0, y1, y2, y3. What is the y equals to S0 bar, S1 bar, y0 plus S0 bar, S1, y1 plus add all those things with the numbers. I am going to draw the circuit diagram of this truth table. Can be write it. I'm going to draw that one circuit diagram for that one. I'm going to take that one color. Yes, S0 and S1 bar. S1 bar. Yes, this is the Y0 can be write it like that one. First, I'm going to write the S0, S0 bar, S1, S1, S1 bar it is there. S0 bar. Yes, first one is a S0 bar and S1 bar. S0 bar, S1 bar and gate, that is Y0. S0 bar and S1. This is the Y1. S0, S0, S1 bar. This is the Y2. S1 is a Y3. You have to add all those things with the OR gate, that is call it as a Y. That is call it as a Y can be write it. This is the way to draw the 4 is to 1 multiplexer. 4 is to 1 multiplexer. These are the many of the advantages or applications are there. In your wireless communications, it is the mux are the very important role to play for that one. This is the circuit diagram of the logic circuit of the 4 is to 2 mux. Yes, this is what it comes. S naught bar and A or B or S naught and S1 place you have to take the, instead of S naught equals to A, S1 equals to B. Why instead of D naught, D1, D2, D3 can we take that one? First one is a S naught bar and S1 bar is a Y naught. In place of Y naught you have to take that take it as a D naught. D naught equals to S naught bar S1 bar. Otherwise can we take it as a S naught bar and AB can we take it? Instead of that one, A bar, B bar. In the D1 equals to A bar, B. A bar is here, B is here. With the D1, with the D1. With the D2 can be use it. This is a Y0, Y1. Can we write it like that one? This is the output. Yes. Next is a D2 equals to what it comes like that one. A, B bar. D3 equals to AB. Can we write it like that one in the for the multiplexer? Can we write it in the mux? AB equals to 0 and gate is unable to use that one. This is the way to write the mux diagrams. Yes, can we write it like that one? These are the inputs. These are the can we explain about the demultiplexer? Demultiplexer is the reverse of the mux. In the mux, many of the inputs given, only one output can we take that one. Here is only one input, we can get the n number of the outputs. In the demultiplexer can we use it in the demultiplexer? We are giving the only one input. We are giving the only one input. We are getting the 2 raised to n number of the output. Y is the input. Only one input. We are getting the 2 raised to n number of the output. N is the serial numbers. N number of the serial lines. These serial lines are using for that one. What is the need of that one? If you are getting, it will tell the which one is the output and which one is the input. This serial number will decides acts like a switches. If you on the 00 line, the 2 raised to like that one in the mux 00 line, if you are providing the line, it will tell that one which is the circuit is on, that can be tell it like that one, right? That is the way to understand of for that one. Yes. And then the most of the uses are there for the demultiplexer also. The most of the usages of the demultiplexer, audio and the video can be used for that one. Yes, the many of the users of security systems, these are the audio video, they can multiplexers are using only one input given. You are getting the LAN circuit also. One line can be given, WAN, wide area network, can be, for example, if your LAN connection it is there in your home, if you are giving the only one input for that one, if you are connected to LAN into the many of the outputs. For example, your hotspots, mobile hotspots. If your mobile hotspots, if you are on that one from your one only one mobiles, if you are connecting to the many of the signals, uh, there also they can use like the multiplexers, demultiplexers. Only one input it is there. Many of the outputs can be give that one. That is the serial numbers, that is the IP address can be, have you you have note that one for example. Mhm. This is the way to use for the demux. This is the only one input, it is the 2 raised to n number of the outputs. I'm going to explain about the truth table of the 2 is to 1, sorry, 1 is to 2 demux. It is the demux for the block diagram can be used. Two outputs are there, D0 and D1. Serial numbers, how can we get that one? 2 raised to n is a 2 means it is a 1. Yes, can we take it as a S0 is a 1, D0 and the D1 is a output, and Y is a input. Y is a input. I am going to write the D as a input. D means if it is 0 or 1. Don't know. Yes, D can be write it. S0 is write it as a 0 or a 1. The two conditions. In these conditions, 0 it is there, 0 it is there. Can we write it in the mux? Can we write it in the D mux? Can we use it? This is the high, this is the 0. This is the high, this is the 0, and in this serial it is a 0. Yes, D naught is a on. D, yes, otherwise when it is there, D is on. Yes, it decides the serial line, but with multiply by with this input. Multiply by with this inputs. How can we write that one? Can we see that? How can we write it like that? I'm going to just, how can we write it like that one? In the demarks, can we write it? Yes, y naught equals to D is a input with S naught bar. S naught bar. Y1 equals to separate D into S naught. Can we draw the circuit diagram for that one? Can we draw the circuit diagram for that one? Can we draw the circuit diagram for that one? Can we draw the circuit for this one? Is it is a multiplication? Yes. Can we write it in the circuit diagrams? It is D is a input, S naught bar. Yes, S naught bar into D. Yes, this is the Y naught. D into S naught is a Y1. This is the circuit diagram of the 1:2 D mux. D mux can be explained. Yes, in the same way, I am going to explain about the 1:4 D mux. 1:4 D mux. 1:4 D mux. Can we write it here as a 1, 2, 3, 4. Serial numbers are 2, S0 and S1. Y is a input. D0, D1, D2, D3 are the outputs. Output. I'm going to write the truth table for this one. I'm going to write the truth table for this one. S0 and the S1 with the Y. Y is D, 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 D. 4 numbers 0, 0, 1, 1, 0, 1, 0, 1. D0, D1, D2, D3. Yes, this is the way to write that one. I am going to write D0 is a high, D1 is a high, D2 is a high, D3 is a high. Remaining all are zeros. These are the zeros. Yes, I am going to write the D0 value. I am going to write the D0 value. How can we write that one? Yes, I am going to write the D0 value. D0 equals to what it comes? S0 bar, S1 bar into D. D1 equals to S0 bar, S1 into D. D2. equals to S naught S1 bar D D3 S naught S1 D. Yes, I am going to write the circuit diagram for this truth table. That circuit diagram for this circuit can be write it S naught S naught bar S1 S1 bar. Yes, first one is a D naught equals to S naught bar S naught bar S1 bar equals to D naught with the D with the D. Hmm, with the D. Yes, next one S naught bar D S1 is a D1. Third one is a S naught S1 D S1 bar is a D2 and D3 is a S1 S2 and D is a D3. D0, D1, D2, D3. Yes, this is the output. These are the outputs. D is a Y is a input can be multiplied by this equation. By these equations can we see it like that one. This is the way to explain about the 4 is to 1 mux. This is the data. This is the data is a input. Yes, these are the outputs. Can we write it in the like that in the logic circuits? Yes, this is the way to explain about the multiplexer and the multiplexers. Yes, and one example I am going to take that one. You have to use the mux and to explain about the equations. Yes, I am going to explain about this one example for that one. Example that is yes x f of summation n into 1 2 3 6 7 is a using the mux ಅಂತ ಕೇಳಿದ್ದಾರೆ ಕ್ವಶನ್ಸ್. ಆವಾಗ ನೀವು ತಿಳ್ಕೊಡ್ರಿ ಹೈಯೆಸ್ಟ್ ನಂಬರ್ ಎಷ್ಟಿದೆ. ಹೈಯೆಸ್ಟ್ ನಂಬರ್ ಇಟ್ ಈಸ್ ಅ 7. 7 ಅಂದರೆ 8 ನಂಬರ್ಸ್ ಬರ್ತಾವೆ. 8 ನಂಬರ್ಸ್ ಆರ್ ದ ಆಕ್ಟಲ್ ನಂಬರ್ಸ್. ಆಕ್ಟಲ್ ನಂಬರ್ಸಲ್ಲಿ ಎಷ್ಟು ಇನ್ಪುಟ್ಸ್ ಬರ್ತವೆ. 2 3 ಅಂದರೆ ಎನ್ ಈಕ್ವಲ್ಸ್ ಟು ಎಷ್ಟು ಬರಬೇಕು. ಸೀರಿಯಲ್ ನಂಬರ್ಸು 3 ಬರಬೇಕು. ಸೀರಿಯಲ್ ನಂಬರ್ಸ್ 3 ಬಂದರೆ ಯಾವ್ಯಾವ್ದು ಬರ್ತದೆ. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಬೌಟ್ ವಾಟ್ ಆರ್ ದ ಸೀರಿಯಲ್ ನಂಬರ್ಸ್. ಎಸ್ ಎಸ್ ನಾಟ್ S1 S2 3 ನಂಬರ್ಸ್ ಬಂದ್ವಾ. ಈಗ ಅದಕ್ಕೆ ಇನ್ಪುಟ್ ಹೆಂಗೆ ಹಾಕ್ತೀರಾ. 0 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 5 6 7 8. Yes, I am going to tell that one. It is a mux. Mux means only one output. Y is the output. I am going to tell that one. 1. Where is the 1? 0 0 1. It is a high. 0 it is there. 2, 0, 1, 2, 3, 4, 5, 6, 7. 3 is high. 4, 5 is 0, 0. 6, 7 is a high. 6, 7 is a high. I am going to draw that one. Y is the output. Marks 8 is to 1. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 1, 2, 3, 1, 2, 3, 3. 4, 5 is a 0. 6, 7 is a high. This is the way to write that one. Why? If they may ask for your examinations, you have to write the value of the y. You have to add the value of the y. Serial numbers 1, 2, 3. A, B, C it is there. 0, 1, 0. What is the output? 2 is the output. 2 is the output. What is the 1? ಅಕಸ್ಮಾತಾಗಿ 2 ಕೊಟ್ಟಿದ್ರೆ 1 ಹೈ ಇದ್ದ ವ್ಯಾಲ್ಯೂ ಬರ್ತದೆ. ಎರಡನೇ ನಂಬರ್ ಏನಿದೆ ಹೈ ಇದೆ. ಅಕಸ್ಮಾತಾಗಿ ನಿಮಗೆ 100 ಎ ಬಿ ಸಿ ವ್ಯಾಲ್ಯೂ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? 100 ಕೊಟ್ಟಿದ್ದಾರೆ. 4. ವಾಟ್ ಈಸ್ ದ ಔಟ್ಪುಟ್? ಔಟ್ಪುಟ್ ಈಸ್ 0. ಆ್ಯಡ್ ಆದರೂ ಇದನ್ನಿಷ್ಟು ಆ್ಯಡ್ ಮಾಡಿರಿ ಅಂತ ಕೇಳಿದರೆ ಆವಾಗ ಏನಾಗುತ್ತೆ? 1 + 1 + 1 ಸಮಥಿಂಗ್ ವಿಲ್ ಕಮ್ ಫಾರ್ ದ್ಯಾಟ್ ಒನ್. ಬೈನರಿ ನಂಬರ್ಸ್ 0 or 1 you have to give that one. These kinds of multiple choice questions they may ask for your exams. This is the number they will give that one. They may ask for your examinations. Keep it in mind. These kinds of questions will come for your examinations. Right? You have to solve more on that one. Sums. Yes? Marks on D marks. Yes? Thank you. So please watch our videos regularly.